Somewhere out there, beyond the reach of telescopes, beyond the orbit of every planet we've ever known, there exists a border. Not a line on a map, not a mathematical abstraction, a real, physical threshold where everything that makes our solar system ours simply ends. For generations, scientists could only theorize about this invisible frontier. They drew it on charts. They debated its properties in journals. They wondered what it would feel like to touch the fabric separating our cosmic home from the infinite dark between stars. But theory became reality when two machines, launched before most of you were born, pierced through that boundary and tasted what lies beyond. And what they discovered wasn't the gentle fade scientists predicted. It was a fortress, a barrier of such compressed violence that it fundamentally changed our understanding of where we live in this galaxy. This is the story of the greatest crossing in human history. Welcome back. Today, we're venturing to a place no human eye will ever see. A boundary so far from Earth that light itself takes nearly a full day to make the journey. But before we can understand what Voyager found out there, we need to understand what we're actually living inside. Our solar system isn't just a collection of rocks orbiting a star. It's a bubble, a magnetic sanctuary carved out of hostile space by the sun's relentless breath. Every second, our star hurls 1,000,000 tons of charged particles into the void, the solar wind. These particles race outward at 1,000,000 miles per hour, creating an invisible sphere of influence that extends far beyond Pluto. We call this protective cocoon the Heliosphere. And somewhere out in the darkness, billions of miles from anything familiar, that bubble has to end. The question that haunted scientists for decades was simple: where and what happens when you cross it? Imagine standing on a beach, watching waves roll toward shore. Close to the water, the waves are powerful, fast, relentless. But as they crawl up the sand, they slow down, spread out, lose their energy. The solar wind does something similar. As it races away from the sun, it eventually runs into something that pushes back. The interstellar medium, the thin but omnipresent matter, drifting between stars. Ancient hydrogen, dust from long-dead supernovas. The remnant pressure of cosmic winds that have been flowing through the galaxy for billions of years. Where these two forces collide, where the sun's influence finally surrenders to the galaxy, that's the Heliopause. For years, scientists imagined this boundary as something gentle, diffuse, like walking from a warm room into cold air, a gradual change you'd barely notice. They predicted that Voyager would drift through a fuzzy transition zone, taking months or even years to fully cross over. The magnetic fields would twist and tangle. Particles would gradually shift from solar to galactic. It would be messy, chaotic, undefined. They were wrong. Because when Voyager finally reached that line, it didn't drift through anything. It struck something solid, something that science never saw coming. August 25th, 2012. Voyager 1 is 19 billion kilometers from home. Its instruments are still functioning, barely, powered by decaying plutonium that's been burning since the Carter administration. And then, in the span of hours, everything changes. The density of solar particles, the wind that had surrounded Voyager for 35 years, drops to almost nothing. Simultaneously, the cosmic radiation from deep space surges by 40%. Voyager 1 has crossed over, but it's not just the particle counts that shock the science teams. It's how abruptly it happens. One moment Voyager is inside our solar system. The next, it's swimming in the medium of the galaxy itself. The boundary is sharp, precise, almost impossibly defined. And there's something else, something the models never predicted. Just inside the boundary, Voyager detects a region of superheated, compressed plasma. It's like the solar wind has been slammed against an invisible wall and crushed into a dense, roiling barrier. The temperature here spikes. The pressure intensifies. It's not a gentle transition, it's a collision zone. 6 years later, Voyager 2 makes its own crossing and confirms what its twin discovered. But Voyager 2 adds one more revelation. The magnetic fields on either side of the Heliopause aren't twisted or tangled. They're aligned, running parallel. As if the sun's magnetic bubble and the galaxy's magnetic currents have somehow learned to flow alongside each other without chaos. It's elegant, structured. Nothing like the turbulent mess scientists predicted. The Heliopause isn't just a line where the sun's influence fades. It's a barrier, a shield. A border wall forged by opposing cosmic forces pressing against each other with unimaginable pressure. And here's what makes that terrifying. If this wall ever fails, everything inside, including us, is exposed to what's waiting on the other side. Let's talk about what the Heliopause is actually protecting us from. Out there, in the space between stars, the galaxy is far from empty. It's filled with radiation, high-energy particles accelerated by supernova explosions, colliding neutron stars, black holes tearing matter apart at the speed of light. These galactic cosmic rays have been traveling for millions of years. They carry enough energy to rip through DNA, shred electronics, ionize atmospheres. The Heliopause stops most of them. Not all. Nothing could, but enough to make the difference between a habitable solar system and a radiation-scorched wasteland. Without this boundary, without the pressure of the solar wind holding back the galaxy, Earth's atmosphere would be bombarded by cosmic radiation at levels hundreds of times higher than what we experience now. And it's not just Earth. Every future Mars mission, every deep space habitat, every human being who ventures beyond low Earth orbit will be stepping closer to this invisible shield's edge. Understanding the Heliopause isn't just cosmic curiosity, it's survival data. But here's where it gets even more fascinating. The Heliopause isn't static, it breathes. As the sun's activity waxes and wanes through its 11-year cycle, the solar wind strengthens and weakens. The boundary shifts. Sometimes the Heliopause pushes outward. Sometimes it contracts inward by billions of kilometers. And as our entire solar system moves through the Milky Way, we pass through regions of space with different densities. When we drift into a denser interstellar cloud, the outside pressure increases. The Heliopause compresses. Our protective bubble shrinks. Some scientists believe that millions of years ago, Earth might have briefly crossed outside the Heliosphere entirely, exposed directly to galactic radiation. It could happen again in the distant future. We live on an island, but that island is sailing through a vast magnetic ocean, and we've only just begun to understand the currents. Right now, as you watch this, both Voyagers are still out there, still sending data back across 22 hours of radio silence. But they are dying. Their plutonium generators lose power every year. One by one, instruments are being shut down to conserve energy. By the early 2030s, the last transmitter will fall silent. The Voyagers will drift on as inert metal ghosts, carrying their golden records into the eternal dark, which is why scientists are already designing what comes next. A modern interstellar probe equipped with sensors Voyager's engineers could never have dreamed of. Better plasma detectors, stronger transmitters. Instruments designed specifically to map the boundary in ways Voyager only glimpsed. Because here's what we still don't know. Is the Heliopause truly the edge of the solar system? Or is there another boundary, the gravitational influence of distant icy bodies in the Oort cloud, that extends 1,000 times farther? Where does the sun's magnetic field finally disconnect entirely from interstellar space? Voyager gave us the first piece of the puzzle, but the full picture is still being drawn. And somewhere in that picture is the answer to a deeper question. What does it mean to leave home? Where does our solar system truly end and the galaxy begin? Maybe it's not a single line, maybe it's layers, boundaries within boundaries, shields within shields, or maybe we never truly leave. Maybe the sun's influence, its gravity, its ancient light extends so far that we're always, in some way, inside its embrace. For the first time in human history, we've touched the boundary. We've run our fingers along the edge of everything we've ever known and felt what lies beyond. Voyager has transformed a mathematical concept into a physical place. A place with temperature, pressure, structure, and meaning. A place that defines the shape of our cosmic home. We live inside a bubble, a fragile membrane of solar wind and magnetic fields, surrounded by an ocean of stars and radiation that stretches beyond comprehension. But that bubble is ours. It's where we were born, where we've lived every moment of our existence, where every thought, every discovery, every story has unfolded. And now, two small machines carry our message beyond that boundary, into the space between stars, into the next chapter of a journey that may never end. The Heliopause isn't the end of our story. It's the beginning of the next one. If you want to follow more journeys to the edges of the known universe, subscribe and let us know which mission we should explore next. From the depths of ocean trenches to the boundaries of space-time itself, we're tracking them all. Thanks for watching. And remember, the universe is bigger than you think, but so is your capacity to understand it.